And we're live! Welcome to RockSim Live, and I can't see myself on the camera. There I am. Oh, I forgot to turn the camera around. Welcome to RockSim Live. I'm Tim Van Milligan. I'm the host. It is Friday, December 19, 2025, and this is episode... Oh, what episode is it? I'm not sure. I think it's number 220. So this is where we talk about RockSim, RockSim Pro, and the Launch Visualizer. And I forgot to put in the chat. We got the chat going. Let me type in the chat, say hello. If you're in the chat and you want to be recognized, go ahead and say hello, and I'll recognize you and where you're from. Because there's a bunch of people that are just starting to join us here. So thank you for coming. And yeah, so let's get to it. So we have Curtis Howe from Michigan. He says he just read the Spaceship Two article. It was very interesting. And he says, thanks for the plans. Somewhere over down there, I've got my Spaceship Two model built and primed, not painted yet. And we have a launch tomorrow, and I'm debating whether or not I want to launch it primed without the paint on it. I don't know. What do you think? We have Gold Spot 804, and he says, hello from Colorado Springs. That's cool. We have Dutch 2-I5T, and he says he's Bill from Indiana. Oh, cool. So that's everybody that's... put something in the chat so far. So if, like I said, if you're in the chat live on YouTube, go ahead and say hello so that I know that you're here. Yeah, it's kind of getting ready for Christmas. Today's the last weekend, your last minute Christmas shopping. My sister Janice just called. Janice, if you're watching, hello. I wasn't lying to you. I did have to go on to this in just a few minutes, and here I am. Yeah, she's doing some last-minute Christmas shopping. I don't know if the rocket kit that she ordered is going to make it there in time because it has rocket motors in it, and it has to go by ground, but we can certainly say Merry Christmas anyway. Say the rocket's in the mail, and it's going to not Rocket Mail. We do have a kit called Rocket Mail, which is a lot of fun. Yeah, so we're here to talk about RockSim, RockSim Pro, and the Launch Visualizer. So if you have a question, now is the time to put it in, because I don't have an agenda. I can just sit here and ramble and ramble and ramble. But I'd rather answer a RockSim question, because that's what we're here for. Curtis House says, launch it to see how it flies. Yeah, so I might. I got to see what the weather is going to be tomorrow. Let me see. Tomorrow, 55 in Colorado Springs. So that means it'll probably be about 60 in Pueblo. That's where we launch. And so that would be a nice day to launch. Maybe I'll go down there and launch. We have Rocket Papa 62. He says he's Rick from Idaho. Well, hello, Rick. I don't recognize that name, so you came here for a reason. I hope that reason is to ask me a question, because that's what I'm here for. Anyway, we have Goldspot 804. He says, I have been able to export my fins from RockSim to 3D print them, but I can't figure out how to export anything else. Okay, well, that's a good question. So let's bring out my screen here. There's my screen. Okay, so here is the Apogee website. We have, our website is apogeerockets.com. We have this banner bar here, and we got a pop-up that says, hey, subscribe to our newsletter and you get 50 free plans. And I would recommend doing that. We put out a newsletter every Tuesday. It's either a newsletter or a video. Next week is a video. So this past week we did a newsletter, and we had the plans for the Spaceship 2-ish, and that's kind of what the plans look like. It was in this issue number 667, and it's a PDF, and you download it, and it has all the plans in there. But then to get the RockSim file, you got to click here on the web page, and the link is also in the newsletter. So you can download that RockSim file so you can play along. So next week will be a video. The last video from last week was how to apply paper skins to balsa fins. Do you like how that rhymes? I was quite proud of that. Next week will be about installing tail cone retainers. So this Spaceship 2, let me see if I can bring this up. I'm scrolling down, sorry for that. So there's a tail cone on here, and so I'll show you how to install it, because there's two important measurements that have to be done simultaneously. So it's kind of like you set one and then you got to adjust for the other one. So I show you how to do that in the video so that when you put it together, everything is nice and tight. You know, we don't want a gap between, the bottom of the tube and the front of the retainer. So that's what the article is about. Again, here is the Spaceship 2-ish. Kind of looks like the Spaceship 2. But it's not a scale model. It's just kind of ish. It was a fun build. Lots of big parts. Got 5 nose cones. So it's got the main nose cone and then 4 other smaller ones on these side pods. So that is what I've been up to. So let me get back to the home page of RockSim. If you scroll down, you got the RockSim live training. This is the archives, which is way out of date because now we're on episode 220, so I'm 25 episodes behind. I'm going to find an AI to help me out with that. But if you go to the how-to and guides menu here and then come down here to software, you can download a free trial of RockSim. There's a RockSim Pro. We also have a free trial of that. And that's, if you go to this banner here, and it says virtually free, that means it's like you can get the trial for 30 days, and then you can extend it. And to get the trial for 30 days, you just have to buy $30 worth of something else. Could be anything. Rocket motors, t-shirts, rocket kits. You got to buy supplies anyway. So then we give you a 30-day trial, and then you can keep doing that every month. So it just keeps that trial going as long as you want to go. You're going to buy rocket stuff anyway. Okay. So that's RockSim Pro, RockSim, and also under how-to and guides, go to software. There's the video tutorials on how to use RockSim. This is like if you're just starting out. What we're doing today can be a lot more advanced. We did some pretty advanced stuff last week. But this is kind of like the basics. The RockSim Pro also has tutorials there. Here's the frequently asked questions, system requirements, and version history, things that we've been changing. All right, so let's get into RockSim. So let's answer that question. So I'm going to be using RockSim Pro, which is pretty much the same as RockSim. Let's open something up. So open recent. Oh, here's a boat tail rocket. Yeah. Like I said, we've been playing around with boat tails. We're just now selling those. These are boat tail retainers. Let me show you what those look like because they're kind of cool. If you go to the home page and you just scroll down to the new products, and you'll see these boat tail retainers. Right now we have them. We've got 3, and they're basically they're all cones, but they fit different diameters. So this fits a 29 millimeter motor mount. So the motor mount is 29 millimeters. And then the outside diameter on this particular cone is 74 millimeters, which is 3-inch. So if you order a 3-inch tube, you can get that one. And then we have a BT80 size, which is 2.6 inches, and then a smaller one at BT70. And all of these are for a tail cone from down to 29 millimeters. So that's what I was working on here when I was playing with this rocket. Let's look at it in 3D. So that is what it looks like. Okay, so he says he could export out his fins to print them in 3D. So to do exporting, first you gotta make sure there's a setting. So under the About, there's a Preferences for RockSim. On the Macintosh, it's under the RockSim Pro menu. I think under Windows, it's under the Help menu. So you would go there, and once you open it, we want to go to the Miscellaneous tab. So you click on that, and you need to make sure that this one is checked. Allow template exports. So you need to make sure that that one's checked, or otherwise you're not going to be able to export. I don't know why we have this as an option. It just should be automatically allowable. Okay, so the next thing you want to do is to find out what you want to export. So he exported fins. So if I click on the fins and double click on it, it'll open up the fin editor. And down here at the bottom, you'll see export template. Now, if you haven't checked that box that I showed you previously, this won't show up. So now this is going to export out a template as an SVG. So this is not 3-dimensional, this is 2-dimensional. So this is like a drawing of the fin, like basically just what you see here. So I'm going to throw it on the desktop and I'm going to hit save. And so it tells me it exported it out. And now I need to open that up. And that is scalable vector graphics, as I said. So in order to open it, you'll need a program that can open vector drawings. And the one that I use personally is Adobe Illustrator, which is what's showing right now. But you can also use, there's a free one called Inkscape. And if you just go on the internet, go to any search bar. Let me go here, Inkscape, download. And you hit tab, you will find where you can download Inkscape. And this is a free vector drawing program. And so I'm going to open that file. I'll just show you what it looks like. So it's on my desktop. And what is it? Okay, so boat tail rocket fin right there. Basically, that's what it's going to look like. But when I open it, it'll show me this on the desktop. And there's my fin. And then from here, I can print it out. So if you want a paper copy, you can print it out. Now, I use this personally also for exporting out fins to send to my laser cutter. So when we design a rocket, one of the ways we can do it is to export it out of RockSim like this. And I can, the laser cutter is just like a printer. It's like, to use it, you just go to File, Print. And it will allow you to select the laser printer from among your choices of printers. And it will just send the file to the laser cutter, and then it will just cut it out. So that is that export right there. And I'll click OK. But there's another way to export, and that is to go here to the File menu, and you can come down and you can export out a 2D model or a 2D image, so that when you go export from here, you're exporting out the entire rocket. So if I export out a 2D model, and I'll just say boat tail rocket, again, I'll put it on the desktop. And again, I'll go back to Illustrator, my program, that I can open vector drawings. I'll go File, Open, and here's the boat tail rocket.svg. Click Open, and when I open it, you can see it's like, there's the screen. Let me see if I can collapse some of these windows to make this bigger. So there's the rocket, and it's got all the parts, and all the parts are clickable. Which is really nice. So that's a tube, but the line width is like very tiny. So if I go here to my line width, and I'll say make it 1 point, you can see now it's much darker. So I use this all the time too. If you look in on our website, in our newsletter that has plans. So if I go back to that plan, let's see if it's in there. Download issue, read it here, download. And if I download the latest issue, okay, and I don't want all this crap. I'm getting to the plan here. So this is the download version of the newsletter. Okay, so this drawing right here is this top part. Let's see if I can zoom this in. You see this drawing right here? That looks very much like what we saw here. And because it is, that's exactly how I made this in the newsletter, is I exported it out and then dropped it into my newsletter. And the beauty of this is a vector graphic. So I can I can't zoom any further in, but if I had unlimited zoom, I can keep zooming in, so you can get down to the very, very fine details. And that's the beauty of vector, is kind of like being able to zoom in. So going back to RockSim, so that was export 2D model, and then you could also export it at 100% scale. So instead of this fitting on an 8.5 by 11 sheet of paper, it would be however long this rocket is. This rocket is 37.86 inches long. So if your printer, your paper was that wide, that's how big it would be. And that allows you to do certain things if you had to scale something, which is really nice. Also here from the export, I can export out a 3D image. So basically taking this image right here, let me go export 3D image. I'll show you what that looks like. So you got to give it a file name. What did I call this one? Boat tail rocket. And you got to browse where you're going to send it to. I'm going to send it to the desktop. And this time it's going to be just a JPEG, which is just artwork. And I'm going to say high resolution. And it's going to say what color background. So, you know, right now it's blue background. And if I click OK, now you can go into the camera controller and you can specify what angle you want to look at the rocket at. So if I do it like this, you know, this is kind of like the same controller that's in the main image. And hit Save Image. I haven't done this in a long time, so then I got to find it on my desktop. So if I go to my desktop, there's the boat tail. Here's the boat tail rocket. Date modified. I swear I put it on the desktop. Did it go? Let's try that one more time. Making sure I selected the desktop. Export out to 3D image. Desktop, boat tail. Why does it not let me type? I got multiple screens open here. Oh, there it is. Save. Okay, so I didn't hit save the first time because it was in another dialog. Date modified. I'm still not seeing it. Huh. Interesting. I don't know where it went. Let me see if I can do a search for it. It's not under oh, there it is. Because it's in the trash. Boat tail. It doesn't seem to be. Let's go by name. Boat tail rocket, SVG, boat tail rocket, SVG. I'm looking for a JPEG. I'm not seeing a JPEG. For some reason, it didn't save. Anyway, let's try the other way. So go back to RockSim, go to File, Export 3D Model. Okay, so this is going to be an OBJ. I can do it as an OBJ, which is basically like an STL. STL is stereolithography. The difference between OBJ and STL is OBJ has colors, where STLs don't have colors associated with them. So if I put it on the desktop, and you'll see it's going to save it as an MTL file, which is the OBJ. There's two parts to it. There's an MTL, and I don't know what the other one. I want OBJ. Okay, there it is. And desktop, save. And it exported that. And here it is right there on my desktop. I'm just dragging the icon there. Let's see what happens when I double click on it. It's trying to open it up in Adobe Dimension. Yeah, I don't want Adobe Dimension, so I'm going to force quit that. Quit. Let me open a Finder window. The cool thing on a Mac is that you can display it. So this is the file. So you can see if I hover over, it says bolttailrocket.obj. You can see that it is 3D, and I can look at it as a 3D model. And this is the same thing with STL files, as you can rotate them around and look at them. You can see the OBJ has the colors associated with it. From here, you can print it out. Although I think you might have some problems printing out different things. Let me see. Let me go back to RockSim. So if I go to the nose cone and I select the nose cone and I open the nose cone, and if I go export template on the nose cone, okay, so here I can export out an STL. So this is the three-dimensional body that you can print. So if I hit save, and it's going to go onto my desktop and it's an STL, click OK. I'm going to go very high resolution, click OK. It exported it. And let's see, I got a lot of junk on my website. Where did it put it? It's called Boat Tail Rocket Nose Cone. Boat Tail go. Here's the nose cone. If I switch back to this, there it is. Okay, so here's the three-dimensional nose cone STL file. So how I did that again was I selected the part and then export template, and then you can select what you want. So you can do that. So if I do it for a body tube, hit cancel here, come to the body tube, hit edit. This one does not give me a choice to export it out. So there's certain items that you can export and certain ones you can't. Let's see if I can do this boat tail back here. So edit. Okay, this one does have an edit button or export button. And if I click on it, put it on the desktop, hit save, and that did export it out. Let me go back to my Finder window so we can see what it looks like. Desktop. Here's the nose cone. Looking for one that says, let's see, there's two files there. And for that one, this is the same. Basically, you got the OBJ part and then the MTL part, and it exports out those two together because this one is the material and this is the shape. Can't find anything in that way. Transition. No, that's. Oh, I exported it out as an SVJ. I didn't want an SVJ. I wanted the STL. Very high resolution. Click OK. And it exported it out. There it is. Let's look at it from the viewer. There it is. So that is what that's going to look like when printed out. It's going to be a solid object. And this is one of the limitations of RockSim when you're exporting out parts is, it's got very limited. It's not a CAD program per se. It's a rocket design program, and being able to export out some parts is nice. But this is what it would look like. So that's how you export. Looks like there's more questions in here, so I better move on. Rocket Papa 62 says, so I am working on two projects interrelated. I am upgrading a baby Bertha to 24 millimeter with a BT60 DD dual deployment. And I'm building a big Bertha upgrade to 29 millimeters. How do you fix overstable? Okay, so on his rocket, he's got, it says overstable, just like this one right here. And this is a common question is, when a rocket is unstable, that is, you definitely have to fix it. When it says stable, it's okay, but when it's overstable, I guess people are concerned about being overstable. So overstable is not bad. It doesn't have to be fixed if you don't want to. And really, the question is, why do you want to fix it? Because to make something less overstable means to make it less stable. And in rocketry, we don't often want to do that. So I would caution against trying to make things less stable. So the way, stability, let me put a rocket motor in here. So to put a rocket motor, let me go back to 2D right here. To put a rocket motor in it, you're going to hit this button up here. I guess we played with this one last week. Choose an engine. When I choose an engine, I want the biggest one that I can get in there. So I'm going to choose is 29 millimeter. should be, yeah, I don't want to go high power. So the biggest I can put in there that without being high power is this one right here, a G80. And I just click OK. So now we went from overstable to it's not telling us that we're even stable. It's like margin of 1 to 2 is our definition of that good range. Being overstable, like I said, is not bad. But what that really means is the distance between the center of gravity, which is this symbol right here, and the center of pressure, which is that one right here, is on this case, it was 1.23 times. So here's the body diameter. You multiply that by 1.23, and that gives you this distance here. So things that are overstable would mean that it's greater than 2 body tube diameters. And so to make it less stable, there's 2 ways you can do it. One is to move the center of pressure forward, and the other one is to move the center of gravity back. So basically, you're just squeezing the distance between those two. So to move the center of pressure forward, one of the things you can do is to make the fins smaller. And then to move the center of gravity back, you put more weight in the back of the rocket. So if I can go, I got this transition here, like say I got some room on the bottom of the transition, I can shove something in there. There's plenty of room inside that transition. So I can do a mass object inside the transition, and it always looks in the database first, which is this. And then I can tell it how much mass. Like I'll put 60 grams in the back, and that's a symbol right here. And as soon as I click OK, watch what happens to that center of gravity. See, it shifted back. And so now, where I was stable, now I'm marginally stable. If I increase this, let's make it 90 grams, it's closer. 120 grams, it's closer still. Let's make it like 160 grams. Really close now. 250. Okay, so at 250, now I went to unstable. So to make things less stable or less overstable, like I said, you only got 2 things you can do. And both of them do the same thing. It squeezes the distance between the center of gravity and the center of pressure. Personally, I wouldn't worry about it. The only thing that overstable means is when it's windy, the rocket's going to weathercock more. So let me make this rocket stable again. So let's make it 100 grams. I want to go a little bit more than that, maybe 130. Okay, so now we got 0.37, so I'm marginally stable. I click OK. Let me see if RockSim Pro is going to work for me today. And let's go see if the flight profile is working, see if I got some credits left. Will it allow me to launch without that in there? I need no. Let me find that stupid thing right here. Delete that. Yes. And now this is a remnant from our discussion last week. I had an extra motor mount tube in there. Flight events, starting state. So this is a 96-inch launch rod. Let me make this 36 inches. I'll make it shorter. And I want to launch straight up. And I'm not sure where this is. But I got an 8-mile-an-hour wind. If I hit flight profile, let's see what happens. So I am marginally stable right now. I don't have maps. I got no juice today. This is one of the problems that we're trying to fix. It's not a problem per se. it's a problem with Microsoft. Not Microsoft, with Google, because we're getting the images that are usually in the background from Google, and we're going over our quota every single day, which means that a lot of people are using this every day. And because of that, they've taken away our maps. So you can't see what this rocket is doing. But if I hit launch, you can see the trajectory is mostly straight up. If I zoom out a little bit, and if I go to a trajectory view, okay, I am arcing over. So the launch point was right there. Just trying to see. Wow, we're doing a big loop here. Oh, look at that. I have never made this rocket as it was coming down. The parachute must not be deploying because it's sliding and gliding, which is what that shape tells us. This is the orientation of the rocket. So up until Apogee, it was going pretty straight. And you can see this is nice and straight. And that's what I wanted to show you, that the upward trajectory is pretty straight because this is a marginally stable rocket. Let's make it overstable again. So if I go to the rocket design components, find that mass and delete the mass, and say yes. And so now we are, now we got a margin of 1.09. Now I'm going to put some weight in the nose cone. So again, I want to move the center of gravity forward to make the distance between these two more. And so this time instead of putting it in the butt end, I'm going to put it in the front end. And let's add, what did I say before, 130 grams? And I want to put it right there. So now you can see that our center of gravity is way up here. And we are 3.36 calibers. So that means that the distance between these is 3.36 times the diameter of the tube. So I haven't changed anything else except I've moved the location of the weight of the mass from the back end to the front end. So I just swapped its position. And when we do a launch, let's see here, I can kind of see that it went lower. And I want to make this trajectory view. So my rocket is right there when we launch. I'm not seeing anything. Okay, I need to spin this around. Hopefully you can see this. And if I zoom out, you can see it's not quite as straight as the first one. In fact, in RockSim Pro, one of the things that we can do is I can select both of these together and then hit the flight profile button. And it will show me a comparison of the launch. And let's see if we can see something. So I'm going to just stop it at Apogee. And I want to go to trajectory view. And let me zoom out and spin this around. Whoa, look at this. One went one way, one went the other way. Which one is which? I think this one was the one that was overstable and it arced into the wind. And this one was marginally stable and the wind didn't affect it. So that's basically what I'm trying to show, is the trajectory is going to change depending on the distance between those two. So overstable, this one's overstable. This one was marginally stable. And you can see that didn't make much difference. So why do you want to change something? Explorer 828, he says, David from Michigan, it's cold and snowy. Launch tomorrow is canceled again. I'm sorry to hear that, David. Dutch 2-I5T says, RockSim shows approximately full calibrability stability for Aspire and Zephyr. Any tips to reduce overstability without changing the sleep profile? Yeah, like I did here, to change the stability without changing the profile is you're shifting weight around inside the rocket. And basically that's the only thing you can do and that will change your center of gravity. The center of pressure is what the shape of the rocket controls. This is all your aerodynamic forces. So it's only the external part of the rocket that changes that. So that should be an easy question. Johan is here, and he says, turned 2 nose cones the past month from balsa with an improvised lathe. Not easy to get them exactly round. That is so true of balsa wood. Balsa is very hard to turn on a lathe. My suggestion is for tips on sanding balsa or carving balsa on a lathe is high speed. Balsa is so soft that you want to go high speed, and that's if you're using a cutting bit. Now, the best way to do balsa wood, and the way that we used to do it when we made balsa nose cones, is instead of cutting them, we sanded them. So imagine a kind of like an emery board. You're sanding away the balsa wood instead of cutting it. And that gives you a finer surface. It takes a little longer, but it allows you to keep the dimensions closer to what you want. Rocket Papa 62 says, yes, he's doing dual deployment on his Baby Bertha to 24 millimeter. And he's concerned with the safety aspect, and he says he appreciates the information. Yeah, so being overstable, if you ever go up to an RSO and they balance your rocket and they notice that it's really nose heavy, they're not gonna deny you of launch, because basically more weight in the nose means the rocket is more predictable. They know where it's going to go. It's like when we launched that marginally stable rocket, it kind of surprised me that it didn't go into the wind. It went with the wind. And that's the problem with marginally stable and unstable, is you don't know where they're going to go. So yeah, being overstable is not bad. Yeah, and Johan says, yes, I sanded them too. Makes them smooth surface with 400 grit. A chisel makes it splinter. And that's what I was getting at, is yeah, you don't want to use a chisel bit on balsa wood when you're sanding it, or trying to turn it on a lathe. The harder the wood, if you get some balsa wood that's hard, it turns better, but then it's heavier, So kind of like, what do you want? You want a heavy nose cone, or you want one that's dimensionally more accurate? Yeah. I think that's all the questions so far. Send in more questions. Let me take a sip of water. What else have I been working on? It's like I said, we just released the tail cone retainers this week. We also released the upload rocket. I think last week I talked about the upload rocket, but I couldn't show you what it looked like. So don't save that. Where's my website? Where's the website? There it is. So the upload rocket is this one right here. And this one we developed in collaboration with Mark Rapella, and he has a YouTube channel called Project Horizon. He does advanced stuff. And in his latest episode, he's doing a rocket that de-spins. And the purpose of de-spinning is he wants to control the trajectory of the rocket. And having the rocket spin like that makes it harder to control, where, eventually he wants to, like, I want to go that way, or I want to go up, or I launched this way, but I want to go up. When it's spinning, it's a little harder to control. So by de-spinning it first, then he can control, the direction better. So that's what his project is right now, and he talks about it and all the electronics and the servos and the flight computer and the software that he has to write. And then, we said, hey, you got all these subscribers. Why don't you, let's sponsor you and let's make a kit and make some money on it. So he said, sure. So we created the Upload rocket. And this thing launches great. It's a simple rocket. It's not huge. He's not putting any of his electronics in it, because to de-spin, he uses canards up front. This is just for kind of like beginners that have done Estes kits before, but they want to go mid-power, but still have something that's really easy to build. This has through-the-wall fins, nylon parachute, Kevlar shock cord, plastic nose cones, massive amounts of vinyl decals. Right there, you can just barely see the slots for the fins, because it is a through-the-wall fin. So we cut the slots in there for you. There's the nose cone. Oh, you get a plastic retainer. We give you that. Well, it's one of our new 3D printed retainers. Basswood fins. Those are the decals. The instruction sheets are the Apogee instructions, so they're really good. Nylon chute. Yeah, so that's the Upload kit. So that was also released this week. So it's been a busy week. And next week is Christmas, so we're not releasing anything during Christmas week. We will be here. Christmas Eve, we'll probably be out of here early in the morning. Just basically the delivery companies are still delivering packages. So they might show up with something for us, I don't know, tubes or nose cones or something. So we'll have somebody here. I'll be here because that way my staff can take some time off and visit with their family. Then we'll be off on Christmas Day, but we will be back on Friday, the 26th. Because a lot of people stay home and then they get on their computer because they're tired of watching football or whatever. So Thursday night football is our Denver Broncos are playing Kansas City Chiefs, so I'll be watching football. And Curtis Howe says, do you plan on making tail cone retainers for 18 or 24 millimeters? So that's a question that we've had so here are those tail cone retainers again. So all of these are 29 millimeter in diameter for 29 millimeter. And my thought is if these sell well, why not do other sizes, 18, 20, I don't know about 18, 24, 38 millimeter. There's already 38 millimeter from Aeropack. They make aluminum ones. They're quite a bit more expensive, but the same thing. So we started with 29 millimeter because nobody was doing 29 millimeter, so we did 29. So we might do, I guess the next easiest one would be 24. And we got some other retainers coming out that are going to be really cool. I'll talk about those in a couple weeks. Dutch 2-I5T says, as a TR level 2 member, what best practices do you use to validate ejection charge timing and altimeter-based deployment against RockSim open rocket predictions? To validate, and he just retracted the message. Well, the electronics is automatically going to deploy the drogue chute at Apogee. So you have no way of validating that. It's just going to go based on the altitude. And where do you deploy your main chute? And the whole purpose of dual deployment is so you don't have to walk as far. So hopefully you deploy your main chute low enough that it's not a long walk to retrieve it. As soon as that main chute comes out, it's going to really slow down, and then the wind is going to catch it and push it. So ideally, you want to deploy it as low as possible, but you got to have some fudge factor in there, like how fast does it take for your parachute, once it's out of the tube, to unfurl and fully open, and you want some factor of safety in there. So it could be, most people, they don't want to go below 600 feet. And usually it's, the bigger the rocket, the higher it is. Because they just want to have, if the parachute doesn't deploy, and it deploys, it's out but not open, it's still going to come down hard, but it's going to give you time to warn people to get out of the way. You can hit that bullhorn or, the air horn and make a lot of noise that hopefully wherever that rocket's coming down, the people can be alerted and have time to look up and get out of the way. That's the whole purpose is, safety. The lower that it comes down before that main parachute is deployed, you're not going to have a lot of time to warn people. But you're going to have a shorter walk if everything works right. So what I would show you is if the RockSim Pro Launch Visualizer was working, you could go in there and play around with the altitude that it's deploying and then see how far away it projects that it's going to land. And then at that point you say, I don't want it to land that far away, which means that I need to deploy lower in the air, so closer to the ground. There's always a trade-off, and then you got to recognize that. Any other questions? We're getting close to 3 o'clock, but I feel like I owe you all the way to 3 o'clock. So I'm talking about other things. Yeah, we got some plans for next year. Yeah, there's some cool plans for next year that we're working on. Don't want to talk about it too early yet. In January, I do have to go to, I think, 2 diving meets that my daughter has. She just had 1 diving meet today, and I didn't go to it. And I feel really bad because she texted and there's nobody in the stands. There's no spectators for a diving meet, and so that's kind of sad. Explorer 828 says, how do you determine parachute size with RockSim? Well, that's a good question. Okay, so here's a rocket, and what we're looking at, here's the parachute. It's like, is this parachute the right size? So let me move this over. Am I getting it all on screen? Okay, I am. So we're going to go to the Rocket Design Components tab, and you want to find your parachute. And so you might not have a parachute yet, but if it doesn't, add a parachute, okay, so that we can open it up and look at it. So once we open it up and look at it, the thing that we're looking at first is the calculated descent mass. So this is the mass of the rocket that RockSim thinks it's going to be at when the parachute opens. So now compare that mass right here to this mass down here. So down here it's 545 grams. This is 476. So what is the difference between those? And the difference is the amount of propellant inside the rocket motor. So RockSim has said when it's coming down, there's no propellant in it. We have a motor, but no propellant. And so that's what this calculated descent mass is. So based on that descent mass, now we can decide what size parachute. And what we're looking for is a descent rate. So right now we have a descent rate for whatever size parachute, and this is a 24-inch diameter chute, and it's coming down at 14.5 miles per hour. And so the question is, when you're designing a parachute, is how fast do you want the rocket to land? And my rule of thumb is about 15 miles an hour. So this is not too far away. So this is pretty close. That's slower than 15 miles an hour. So some rockets, if they're built really strong, they can survive higher landing speeds. So if it's all fiberglass, it can survive higher landing speeds. So you can go to a higher descent rate than this. So in RockSim, you'll see there's 3 preset descent rates: a low descent rate, a medium descent rate, and a high descent rate. So if I click on the high descent rate, maybe my descent rate was 8 miles an hour. I don't know. I thought it was. Here the high descent rate is 10 miles an hour, which is a lot lower than the 15 that I have. And this gives me an outer diameter of 34 inches. If I click on the medium button, these are like backwards, because that's a lower descent rate. And this is a low rate at 7 miles, so anywhere between 7 and 10. So if the rocket was built strong, you could hit the high rate. If it's built average, hit medium. And if it's the low descent rate, if it's not built strong, or it has things hanging off the side of the rocket, like big pods, things on the tips of the fins that could get knocked off, then you want a low descent rate. So that's kind of like my philosophy. If it has things on the side of the rocket, I'm going to hit the low button. If it's just your normal rocket made out of paper and balsa or wood, hit the medium button. And if it's fiberglass or carbon fiber, hit the high rate. And that's going to give you smaller parachutes. And so that's how you determine the size. And if you want more information than that, then you go to the Apogee website. You go to How-To and Guides. You come down here to Peak Flight Newsletter. You come over here to All Newsletters. And then you do a find, which is Command F or Control F on Windows. And it brings up this search bar here. And I can type in the word parachute. And it's used 51 times. And I'm going to just flick through them until I find the article that I want. Conical parachutes. Creating gliding parachutes, upgrading low power parachutes, ejecting parachutes, how to build a mesh chute, the Mars parachute. There it is. Issue number 496. What size parachute should I use? If you click on that, it'll give you an article, which is basically something very similar, and it gives you charts. So if you have a hexagon parachute, and I have let's see, my mass here was, what did we say, 460 something? So a mass between 415 and 565, somewhere around 36 to 42 inch parachute. And yeah, so that's kind of, if you wanted a high descent rate, you can go down to a 30-inch parachute for that size. And so there's parachute charts, but it's a lot easier in RockSim because there's 3 buttons. You just hit the right button and it just says, use that size parachute. And as long as you're within, you know, plus or minus 4 inches, 5 inches, you're probably going to be okay. Good question. I think we'll make that one the last question. Okay, so yeah, like I said, we will be here Friday the 26th, the day after Christmas. I might be the only one here. You know, a lot of people have time off, so if you want to do something, you can join me here. Same time, 2 p.m. Mountain Time, 4 p.m. on the East Coast. Yeah. It's going to be a slow week. Say hello, buy something, keeps us employed. Yeah, and if you're launching tomorrow, I hope you have a good launch. We have a launch, and I'm still debating whether or not I'm going to go. And then will I fly the Spaceship 2-ish? I'm kind of itching to fly it though. It's built, it's ready to fly. You just have to throw a parachute in it, and it's ready to go. Okay, so I hope you have a Merry Christmas. You know, yeah, like I said, yeah, just have a great Christmas. Enjoy your family, enjoy your friends. Yeah, and then hopefully we'll see you on Friday. So I'll give you a countdown and we'll get out of here. So in 5, 4, 3, 2, 1, go out and launch.